Here we are going to solve for the image of vector v and the preimage of vector w using this given matrix, as we have here a linear transformation defined by a matrix. The linear transformation defined by a matrix can be written in this form. The transformation of vector v is equal to the product of your matrix A times your vector v. We can solve for the image of v when this is actually plotted. But before we start, there is also an important connection as to, even without these two given here, you are able to understand what is the form of the image, or what are they vectors that can be found in the domain and the codomain. Our matrix here is a 2 by 3 matrix. We have 2 rows times 3 columns, where it could be m by n here, being m is the number of rows and n is number of columns. The transformation defined by any matrix is a transformation from r to the power of n to rm. This would mean that using the value of m and n here, our transformation here for this given example is defined as the transformation from R3 to R2. Okay? With this, we can see that vector v here is really a part of our domain, as it is an element of R3. And our w here is part of the codomain, as we have here R2. This would mean that the image of vector v is an element of R2, and the preimage of vector w is an element of R3. So again, let's try to illustrate that in solving for the first, the image of vector v. So we have here matrix A, 0, 1, 2, negative 2, 0, and 0. To be multiplied, okay, take note that we're moving from R3, okay? So this is, of course, a vector with or a vector or element of R3. You have 6, 1, 1. And of course, you would know that your understanding is correct when you see this to have a defined product, because we have here to multiply 3 entries to this entry. That would mean our answer is really, our understanding of the transformation is really correct. So we will have here a result of a vector which is element of R2, because once you do this, you will have this form. 0 times 6 is 0, 1 times 1 is 1, 2 times 1 is 2, so 1 plus 2 we have here 3. The next one here is negative 2 times 6 is negative 12, we have 0, 0, so negative 12. Notice that the image of our v is an element of R2. So again, it's part of our definition for the linear transformation in this given matrix here. This would mean, this is now the image of vector v. If you would like this to be in a form of a vector, so we have here 3 and negative 12. So same understanding, we can now solve for the preimage of vector w, which is a little bit trickier because you need to really look at the relationship between the coefficients in this form. As once we multiply the matrix A into a certain vector v, and we know that our vector v here is an element of R3, just like this. So we have here a representation for our vector v. Must be a combination of v sub 1, v sub 2, and v sub 3. And if we're going to multiply it here, our expected result is again this w, which is an element of R2. So you have here 0, 1, 2, negative 2, 0, 0, to be multiplied again with vector v with 3 different components. And this would result to our vector w, which is given as 3 and 5. Once you do this, you might have some equations formed here. The first equation is 0 times v sub 1 is 0, 1 times v sub 2, so you have v sub 2 plus 2 times v sub 3, 2 v sub 3 is equal to 3. And then you will have here your v sub 1, you have negative 2 v sub 1 is equal to, plus 0 v sub 2 plus 0 v sub 3 is equal to 5. this would mean our v sub 1 is negative 5 halves. Okay, so this is our v sub 1, the component for the first component for the pre-image of vector w. However, when we look at this equation here, we see that there are two variables here, v sub 2 and v sub 3. What can we do here is when we let our v sub 3 equal to our arbitrary constant t. And this would mean our v sub 2 plus 2v sub 3, which equal to 3, will become v sub 2 plus 2t is equal to 3. Our v sub 2 now is equal to 3 minus 2t. This would mean our preimage, okay, let me write it here, the preimage of vector w, okay, pardon my handwriting, let me do it again. Okay. You'll have here the image of your vector w is a certain vector v with these components. You have v sub 1 negative 5 halves, your v sub 2 is 3 minus 2t, and then your v sub 3 is t. But of course, this is not exact, so much better to come up, whenever you have an arbitrary constant, much better to come up with a set. So we'll have here negative 5 halves, 3 minus 2t, and t, such that t is an element of a real number. In short, there are infinitely many possible pre-image for w as long as t would be any constant or any element of the real numbers. This is how we solve the pre-image and image of a vector under a linear transformation that is defined by a given matrix. Of course, this is very important as part of our analysis. Thank you very much for watching.